Ano ba nangyari? Bakit
Kanina,
nawala yung generator 1?
una nag-alarma yung yung low insulation sir. Tapos nakita ko dito, tinig ko yung RPM niya. Magkaiba sila. Malayo yung differential nila. Yung number 1, 1,860 na plus sir. Tapos ito, 1,800 ganun lang. 1,800
Tapos,
ganun sir. Tapos yun, bigla siya bigla siya na-trip.
nag-trip.
Oo,
Bumitaw siya.
bumitaw yung 1.
Tapos yung 2 pumasok. Ilang segundo pumasok?
siya. Buti yung pumasok siya agad kasi naka-semi-auto siya agad dito.
Naka-semi-auto. Saan yung semi-auto dyan? Ah, ito.
Semi-auto agad yan.
Ikaw ginanyan mo kaagad. Kaya pumasok yung 2. Ayos. Very good.
Bigla siya
Sige.
pumasok.
Checkin natin yan. Bakit nagkaganon? Ayan guys, meron tayong problema sa generator number 1. Checkin natin. Kasama natin si Port Engineer Arjun. Yan mga guys. Subscribe na kayo sa vlog na ito. Para sa inyo to. Watch out. Fuel adjustment having to do with the engine, exhaust smoke at startup. It can be minimized by completing the following adjustment. Place the engine in idle by connecting the terminal M and G. So on a given drawing, we have to connect the terminal M. This is the idle, connected directly on our terminal. This connection going to our terminal G. That is the first procedure. Then we have to adjust the idle speed for as low as speed setting as the application allows. So normally our RPM value for our generator we have on board is 1,800 RPM. Speed idle means you have to run your generator without load and then adjust the starting fuel counterclockwise until the engine speed begins to fall. Increase the starting fuel slightly so that the idle speed is returned to the desired level. So by adjusting a fuel by counterclockwise, you will be able to lower the speed, and by slightly increase the starting fuel by clockwise direction, you will obtain a desired speed level. So in here you have a potentiometer inside. So this is your starting fuel. What you're gonna need to do is connect the terminal M, that is M, and that is a G. You have to put a wire on it. So while the engine is running at idle and you see that your engine emitting very dark smoke on it, you must need to rotate this potentiometer in counterclockwise direction. So you will see the actuator begin to retract and the fuel will be minimized going to your engine, so you will be able to reduce the smoke and the RPM. Then gradually rotate this potentiometer in a clockwise direction. By rotating in a clockwise direction, you obtain a desired RPM value by 9,800 RPM as rated on your engine. So after performing 1, 2, and 3, you will stop the engine. One of the two methods of operation for the SD55E may now be selected. Method 1, set the engine and accelerate directly to the operating speed or generator set, etc. Method 2, start the engine and control at an idle speed for a period of time prior to accelerating to the operating speed. This method separates the starting process so that each may optimize for the lowest smoke emission. So that is the use of our fuel adjustment, which is stated here is starting fuel. Okay, we have also here method 1 and method 2. Remove the connection between the terminal M and G. Start the engine and adjust the speed ramping for the least smoke on acceleration from idle to rated speed. Our rated speed again is 9,800 revolution per minute. If the starting smoke is excessive, the starting fuel may need to be adjusted slightly counterclockwise. If the starting time is too long, the starting fuel may need to be adjusted slightly clockwise. So you may observe if you start the engine and it takes long time before it takes on its rated RPM, you must need to rotate the fuel starting by a clockwise direction. And if you see that during starting time, while the starting fuel is rotated in a full clockwise, just rotate it in a counterclockwise to reduce the smoke emission, provided the terminal M and G is removed or disconnected. That is the method number 1. Method number 2, replace the connection between terminal M and G with switch, meaning you have to put a switch on terminal M and G. Like this is stated here, we have one switch, okay, from terminal M and going to our G. Usually an oil pressure switch, okay. Start the engine if the starting smoke is excessive. The starting fuel may need to be adjusted slightly counterclockwise. If the starting time is too long, the starting fuel may need to be adjusted slightly counterclockwise. So that is a method number 2. Almost the same, but here you have to remove the connection between M and G, and here you must place a connection between M and G. When the switch open, adjust the speed ramping for the least amount of smoke when accelerating from the idle speed to the rated speed. So we have speed ramping here. So this is our speed ramping. Okay, so starting fuel, you can reduce the smoke emission during the engine is started, and once the rated RPM is takes long time to obtain, you must need to increase the fuel starting. Okay, then it follows by speed ramping. So speed the proper speed ramp time of your generator. So we have here counterclockwise rotation if you want to shorten the speed ramping activity during starting mode. In here also you have the what you call the governor performance. The govern speed set point is increased by clockwise rotation of the speed adjustment control. Remote speed adjustment can be obtained with an optional 5K speed trim control. Okay, this 5K is known as voltage potentiometer. Normally this speed trim control 5K rotated in a clockwise direction, normally seen at the engine control room. So you may have a connection on terminal G going to your trimming resistor or variable resistor here. It has a resistance value 5 kilo ohms connected on letter J. Okay, as you can see here, you have the illustration letter G connected on our resistor, directly connected on letter J, and it has a variable trim resistor here. So there is terminal connection J and G, which was clearly elaborated here, the connection of the resistor J and G with the resistor. Okay, and then there is a trimming potentiometer here from which you will rotate, so it will slides down in a clockwise direction. And we have K and L. K and L is a voltage drop. So as you can see, you have the 5K ohm resistor, meaning you need to select proper potentiometer value from table 1. So this is your table number 1, from which the variable speed range potentiometer value for 1K, the speed range is 900 Hz. For 5 kilo ohm, you have 2400 Hz. For 10 kilo ohms, you have the speed of 3000 Hz. For 25, you have 3500 Hz. And for 50 kilo ohm, you have a 3700 Hz. So by inputting a 1, 5, 10, 25, and 50 kilo ohm value, the speed will have a frequency of 900, 2400, 3000, 3500 to 3700 Hz. So once you have the terminal G and J connected together with a resistor with 5 kilo ohm, you may have a 2400 Hz, from which this signal is processed by this speed regulator to give an equivalent voltage output on our actuator. This is actuator A and B connection, from which this A and B going directly to our actuator. This is actuator, you see, we have A and B. So this actuator normally has operating voltage from 2 volts, 4 volts, 7 volts up to 24 volts, depending on the speed that your engine may require. Actuator will inject fuel much more, so the engine will rotate at constant speed. More loads, it command to inject more fuel on your engine. By principle, more load, it produce more torque that your engine must need to compensate. So the actuator will give more fuel to increase the force that will be able to rotate the engine of your alternator at constant speed. So in here you will see the stability and the gain. Actually it deals with your governor performance. So gain setting, you have also a potentiometer here which has labeled BOURNS. Okay, then 3 we have also 8 and 6. It was labeled like that. And the stability also, we have BOURNS 8 and 6. So gain, in here said, rotate the gain adjustment clockwise until its stability develop. Gradually move the adjustment counterclockwise until stability returns. So move the adjustment 1 division further counterclockwise to ensure stable performance. So that is the use of our gain. Okay, if you rotate it clockwise, there is instability, means there is an erratic performance. Then you have to adjust it counterclockwise, you will gain stability, means stable RPM value of your governor. Okay, on the drawing you have here the gain you can rotate by clockwise to have instability or unstable, then counterclockwise for you to have stable governor performance, which was actuated by our actuator, this one. Aside from our gain potentiometer, we have also the stability. What is the use of our stability? In here we have procedure, rotate the stability adjustment clockwise until instability develop. Instability meaning erratic, okay? Gradually move the adjustment counterclockwise until the instability returns. So stable, you have stable governor performance. Move the adjustment one division further to ensure stable performance. Gain and stability adjustment may require minor changes after engine load is applied. Normally, adjustment made at no load achieve satisfactory performance. A strip chart recorder can be used for further optimized adjustment. So this is the commissioning. If instability cannot be corrected, further performance improvement required. Refer to the section on system troubleshooting. Okay. So we already discussed the starting fuel and speed ramping. Starting fuel is dealing with how much is smoke being generated while the engine is starting at idle, and speed ramping are used for the time required for you to obtain your rated RPM for 1800 RPM. And we have the gain and stability. It pertains to your governor performance, from which you will observe the erratic or stable performance of your governor actuator. And we are going to discuss now the speed and droop and idle. So we have here the idle speed setting. If the idle speed setting was not adjusted as detailed in starting fuel adjustment section, then place the optional external selector switch in the idle position. The idle speed set point is increased by clockwise rotation of the idle adjustment control. When the engine is at idle speed, the speed control until applies droop to the governor system to ensure stable operation. So in here we have idle potentiometer leveled with like this, so you can rotate it also. BOURS 86, okay? That is idle speed, meaning you can set your idle speed. When the generator run without load, you can also get here rated RPM by 1800 RPM. Take note that you may get idle speed increased by rotating in a clockwise direction. We have also here one potentiometer known as droop, labeled BOURNS 3386. Speed droop operation is typically used for paralleling of engine-driven generator. Place the optional external selector switch in the droop position. Droop is increased by clockwise rotation of the droop adjustment control. When in droop operation, the engine speed will decrease as engine load increases. Okay? The percentage of droop is based on the actuator current change from engine no load to full load. A wide range of droop is available with the internal control droop level requirement. Above 10% are unusual. If droop level experiences are higher or lower than those required, contact the factory for assistance. After the droop level has been adjusted, the rated engine speed setting may need to be reset. Check the engine speed and adjust the speed setting accordingly. So that is the use of our droop. Droop is having to do with your generator engine in parallel operation, okay? So normally when you do a parallel operation of your generator inside of the main switchboard control or engine control room, we have a switch there from which you can increase or decrease the RPM of your generator, or you can reduce the load on your generator or increase the frequency of your generator from 60 Hz to 60.1, 60.2, 60.3 Hz before you are going to switch on or put it in parallel with other running generator. So what we have also is the speed. So this is the most important one, the speed of your generator. So in here you will read wide range remote variable speed operation. Simple and effective remote variable speed can be obtained with the ESD 5500E series control unit. A single remote speed adjustment potentiometer can be used to adjust the engine speed continuously over a specific speed range. Select the desired speed range and the corresponding range, okay, with potentiometer value. Refer to table 1. If the exact range cannot be found, select the next higher range potentiometer An additional fixed resistor may be placed across the potentiometer. An additional fixed resistor may be placed across the potentiometer to obtain exact discharge range. Connect the speed range potentiometer as shown in diagram number 2. So, to maintain engine stability at the minimum speed setting, a small amount of droop can be added using a droop adjustment. The maximum speed setting, the governor performance will be near isochronous regardless the droop adjustment setting. Okay, so if you have problem with your speed, you can increase or decrease. By rotating this in counterclockwise, you may reduce your speed. By rotating this in a clockwise, you may increase your speed. So, what we have encountered problem on our generator while I am on board, somebody is installing this one on our generators and we've encountered overspeed trip. And what we do is we put the starting fuel from full clockwise direction to counterclockwise, and also speed ramping from full clockwise rotation to counterclockwise. Then we little bit adjusted the RPM. So in here we adjusted the speed by 1865 RPM to 1810 RPM, and we do select the starting fuel and set point with pointed by SN3, and we set also the ramping speed in between 3 and 8. So in doing this, while the engine without load, we are able to parallel generate with our running generator. If you watch the video I make, you must need to see this also. I'm going to share with you the unsatisfactory performance. If you have a symptoms here, there is a tabulated troubleshooting engine overspeed. Okay, engine overspeed test. Do not crank apply DC power to the governor system. Okay, probable fault, actuator goes to full fuel, then disconnected speed sensor at terminal C and D. If actuator is still at full fuel, speed control until defective. If actuator at minimum fuel position, erroneous speed signal. Check speed sensor data. So this is one of the troubleshooting technique that this operating manual is given. So you can also do manual hold the engine at the desired running speed. Measure the DC voltage between terminal A minus and F plus on the speed control unit. So A minus and A plus on the control unit. From here, you have A minus, okay, from here, and F plus, from here, A and F, as stated here, A minus and F plus. Here we have, if the voltage reading is 1 to 2 volts, speed adjustment set above desired speed, effective speed control unit. If the voltage reading above 2 VDC, actuator or linkage binding. If the voltage reading is below 1 volts, defective speed control unit, gain set too low. So that is the troubleshooting technique that this manual given if you have engine overspeed. So we have also here, actuator does not energize fully. You have to need measure the voltage of the battery while cranking. Normally when I do this one, I measure 4 volts to 24 volts. If the voltage is less than 7 volts for 12 volt system or 14 volts for 24 volt system, replace if battery if it is weak or undersized. Momentary connect terminal A and F. The actuator should move to the full fuel position. The actuator or battery wiring in error, actuator or linkage binding, defective actuator, see actuator troubleshooting. Fuse open, check for short actuator or actuator wiring harness. So, actuator that not energized fully. When I'm on board, I encountered our generator not running at all. It will start but not able to start and run continuously, and we encountered the cable going to our actuator is cut. Engine remain below desired governor speed. Measure the actuator output terminal A and B while running under governor control. So, if voltage measurement is within 2 volt of the battery supply voltage, then fuel control is restricted from reaching full fuel operation, possibly due to interference from the mechanical governor, carburetor, spring, or linkages alignment, speed setting too low. So this is the engine remain below desired speed. Okay, but take note, all of this is a troubleshooting made by the maker. So this is also a hint for you to troubleshoot some problem that you may encounter in maintaining your generators. Also here, we have a satisfactory system inoperative. If the engine governing system not function, the fault may be determined by performing the voltage test described in step 1, 2, 3, and 4. Refer to meter polarity should normally values be indicated as a result of following the troubleshooting step. That fault may be with the actuator or the wiring to the actuator. See the actuator publication for testing details. So we have here step 1, 2, 3, and 4. F plus E minus, battery supply voltage 12 to 24 volts, check. Probable cause, DC battery power not connected, check for blown fuse. Low battery voltage, wiring error. Okay. For terminal C and D, 1.0 volt AC RMS minimum while cranking. The reason may be gap between speed sensor and gear tip to grid, check gap. Normally, the air gap of your speed sensor with gear of your alternator is about 0.45 millimeter. Improper or defective wiring to the speed sensor, resistance between terminal C and D should be 1200 ohms. So the resistance of your sensor must be 1200 ohm between C and D. Where is that C and D? The C and D is here. Okay, C and D, from which your magnetic pickup is connected. You must need to measure here the resistance value by about 1200 ohms here. Okay, defective speed sensor, no problem. Okay, we have here P plus and G minus 10 VDC supply. Short on terminal P, this will cause defective unit, defective speed control. So if you have P and G minus 10 volts internal supply, P and G is connected here, the P and G. P and G. If you measure here, P and G and has a 10 VDC, meaning your speed sensor is defective. Okay. And the last is the F plus and A minus. 1 to 2 volts DC while cranking, speed adjustment set to low. Okay. Short open actuator wiring, defective speed control, defective actuator CO2 troubleshooting. Normally, the speed that you must need to measure on terminal F A minus is more than 1 to 2 volts. When I do a check on it, on my actuator, while the generator is running at 9,865 RPM, I reduce it with 9,810 RPM. The voltage across on A and B going to my actuator is 4.5 to 4.7 volts. Okay, so please watch the video I made to fix the overspeed RPM trick, to fix it, and we will able to parallel the generator number 1 to generator number 2. This is our MEC24-S safety system made by Lindenberg and Lagen, from which you will find a power 24 volts, from which you will see the system failure, the RPM out, RPM in, the overspeed test, and also MEC24 for the start-stop alarm system, having a level of speed regulation, common alarm, control bolt failure, start failure, and as you notice here, everything looks normal, but during our generator runs, the generator trip due to the overspeed. So from local, and we put it in the remote, but we check the RPM, we see that rated RPM of 1,862 revolution per minute is too much high with our RPM value rated 1,800 RPM. So from local, from remote, we put it in local. So we check our starting fuel was pointed on BOU. We adjusted the speed ramping from 3 to S, and we check and pointed it to S. Then we check that RPM keep remain at 1,862 RPM, and then we decrease the starting fuel from O to V, that is a counterclockwise direction. We reduce also the gain from S to R, and we clockwise rotated the starting fuel from B to O, and verify the RPM value of our generator is need to be 1800 revolution per minute while it is rotated in idle position, and we adjusted the speed potentiometer in a counterclockwise direction to reduce the speed, you see, and we do measure the voltage across on our actuator with 4.5 volts. So from 1862 we do manage to decrease it by 1850 to 1851 by continuously measuring the voltage on terminal A and B, voltage across on our actuator. So from 1850 become 1830 to 1832, and you may take note that the speed drop is pointed on between S. Okay, now we have 1825, and our idle speed is pointed on VR about U. See, and after having adjusted by 1810 RPM, we put the starting fuel on U, pointed on U, and ramping is rotated and pointed on S, and reduced by pointed it on 3 and 8, and our starting fuel is pointed on S and 3 in between. So we are able to manage and decrease the speed by 1810 with a voltage across on our actuator 4.56, 4.57, 4.56, 4.54, 4.55 volts across on our actuator. So from remote or from local, we put it in remote, and we check the fuel temperature and the RPM. Now we have 1800 revolution per minute, and we go on the engine room to parallel generator 1 to generator number 2.
1.7, 1.810 talaga.
63, 450. O sige.
Trip yung ano, yung aircon.
59 point. Sige, pasok natin yung isa.
Pasok natin.
Parallel natin.
Ano kaya possible reason ng LED? Kaya yung gobyerno mismo may problema? Ayun. Kasi paano mo giyaw ng fan? Yun siyang fan. Fan sa una ha.
GG1 no? Standby sequence, synchronizing GG1 natin. Silipin natin yung ano niya. Silipin ko lang. Yan. Ay, maganda na yung ano niya. Oh. Pwede na yan. Sige, ano natin.
Baka yan siguro dahil lang no? Nang tagal niya pumasok. No?
Synchronizing.
Ikunin ko na ha. Ikunin ko na ulit.
Yung ano. Okay.
Yan siguro dahil lang ang tagal niya mag-disconnect pa.
Baka hindi siya properly set nung kinabitan niya. Balik kayo ha. Dito sa ano, box defective. Pero bakit wala siyang petsa? Meron. July 2024. July? Yung July, August. 24 ba yan?
Parang bago lang mo.
Oh, 2024 no? 2020.
Nandito pala kayo Port eh. Nagpalit kayo yan. July 2024 eh. 21 yata yan ulit?
21 ba yan?
21 yan. 2021 yan.
Defective. 20.
Pinili ito number 2.
Number 2 naman.
Hindi ba?
Dito ko nga pala. May spare kaya tayo bago nito. Pag wala, order tayo nito. Patik natin doon sa mga ano. Power factor, 0.11. 1 over kilowatts, 60.1 Hz. GE1. GG2. 0.941, 95 kilowatts. 6.3, 450. Mataas ang power factor. Mababa ang kilowatts. So, for tayo na problema ito. And that's it. As you will see, the DG1 now have voltage of 449 volts with 140 kilowatts and power factor of 0.871. And generator number 2 have volts of 449 and power factor of 0.821 with 123 kilowatts. The power factor are almost similar and the frequency also has similar. So guys, ganun na lang. Kay Sir Jeep. Yun.
Guys, subscribe and like,
Share.
share and pautang.
JR Danao, number 1.
Dal Game Farm, 100,000 minimum utang.
Tawagan ko lang. Ha?
Nalawayan, saan yung nalawayan ng ano?
So guys, bibigyan natin
Police,
ng
baka
alkaline water yung aking
Sakay tayo.
mabait na ano rito, heavy guys. Yan. Tangkilikin nyo yung ozonizer natin guys.
Yung nalawayan ng pulis na yun, baka makawa pa tayo ng ano dito.
Meron ba pulis dyan?
Shout out. Masarap yan guys, mineral water.
Nasaan? Teresa?
Ito, hindi naman ng pulis. Mamalakit natin itong ozonizer mga guys. Ayan o. Bili na kayo nito, maganda to sa katawan. Para sa mga health ng sipalol dyan. Talagang tatagal kayo sa barko kahit isang taon kayo sa barko. Hindi kayo mangungulila. Ito, malinis na malinis ang dagat. Yun.